Okay, so the probability that first die is going to come out even. What was that again? 3 out of 6, or 1/2. The probability the second die is going to have a 3 on it. 1 and 6. Multiply them together. 3 and 36, which reduces to 1 and 12. 1 in 12 chance that you would guess both right. Okay, moving on. You roll 2 dice and you add them. What's the probability you roll a 7 or an 8? Well, first of all, figure out 7. Just figure out the probability of rolling a 7. Everybody do that right now. I'll pause. Okay, so out of the 36 things that could happen when you roll a die, what is the probability that you'll get a 7? Well, it's the ones you want over the ones that are possible. There's 36 things that are possible. The ones that work for you are a 1 and a 6, 6 and a 1. What else? 2 and a 5, and a 5 and a 2, and a 3 and a 4, and a 4 and a 3. So that's a total of 1, 2, 3, 4, 5, 6 things, 6 out of 36. Then I got to go to the 8 and do the same exact thing. And now it would be very easy for you to think that when my answer for this comes out to 5 out of 36, that you should take these two and multiply them together. But what would stop you from doing that? What would make you think or? Or means add them. Yes. If it's this or that, remember on the Venn diagrams too, when it was like these people or these people, we added them together. Ors meant we did all 3 parts. So it was like this, and there was a Venn diagram. We took this part and this part and this part and added them all together. Ors are a word that kind of hints that you should add. All right. So add them together. Your final answer is 11 over 36. Okay, moving on. Binomial questions. Binomial, look for something that you could make a big tree for and then say, there's no way he would actually have me make a tree that has 5 separate children, because the first branch would look like this, and then the second kid looks like this, and I have to do 5 separate kids. You imagine how big that tree would be by the time you were done? You'd need all the branches all the way out to here, and I bet there'd be tons. Okay, so anytime you're looking at making a great big tree where all these probabilities stay the same, they don't change like based on the other ones, so they're independent, then do binomial. Who can tell me the framework for binomial, like the skeleton? What does a skeleton look like? Mr. N. Correct. Everybody set up the binomial for this one. All right, here we go. There were 5 children that were going to be born. And I'm going to focus on, there's either boys or girls, and you could focus on either one and get the problem right. If I'm going to use boys, because they were listed first, I would say I'm going to focus on the boys. So there's 3 boys, and this 3 goes here. If the chances are 50-50, or 0.5 probability of each, girls, if this is 3, what does that have to be to make it total 5? Must be a 2. What did you get when you multiplied that all out? Point what? Anybody verify that? Okay, good. All right. This is about a 31% chance that you're going to have 3 boys and 2 girls. If you added up all the things that were possible, all the different combos, like all boys or all girls or 4 boys and 1 girl, etc., they would all have to add up to what? 1 or 100%. Yes? Gotcha. And this next one, if you could see if you can set this one up, number 11, and tell me how your question would be different than it. So for right now, everybody try number 11. It's very much like the last one. I'm going to have the person on the, who did the teaching last time? Person on the left? Person on the right. You explain how to set this one up. I'll pause. By now your teacher has probably explained it. I hope that they said it this way. 5, choose 1. And it could be boys or girls first. It would not matter. But you'd have to, I'll show you what I mean in a second here. If I choose the boys to be the thing I'm focusing on, then I say 1 boy and 1 goes here. then this must be a 4. If I did it with girls being the thing I focus on, it'd be 5, choose 4, because there's 4 girls. I'd put girls first, and I'd put boys second. And the girls is 4, so I put a 4 here. That means this must be a 1. There's still 0.5 and 0.5. Why do those come out exactly the same as each other? Well, these two are just reversed compared to these two. And that's okay to reverse things in math. That's a commutative property of multiplication. And then these two come out to the exact same thing. If you don't believe me, try it. Try 5C1 and 5C4. You'll get the same number. So that's why they will work either way. But whatever you choose to focus on here, that should go right here. So we can always count on those two numbers being the same. So if I use girls, I put the girls first. All right. Moving on to the next kind of problem. Blanks. I think it's best to use blanks whenever you come across a problem that has things that need to be rearranged, like books on a shelf, like kids that are in a line, like candidates for office that have to be up on stage, anything you could rearrange and have on display. Okay, so here we've got a team with 9 members, 9 kids on the team, but the coach does not want the pitcher to be one of the first 4 to bat. Well, I see something like I want to put it in order, I put blanks out. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I ask myself, how many choices do I have? Make 9 blanks right now. Everybody, do this on your own. See if you can find the right combo to multiply. It is not as easy as 9, 8, 7, 6, 5, etc. Okay, so the pitcher can't be in any of those spots, any of those 4 spots. So how many choices do I have for this first spot? You'd normally say 9, but it'd be 8. And if I used one up for that spot, then how many for this spot? 7, 6, 5, and then the only thing that's different is this one now would normally be a 4, but you add the pitcher back in. He can be there. So instead of 4 people, we'd put it back up to 5. And then, again, there's one less person here. 4, 3, 2, 1. Raise your hand if you had that one right. Excellent. A lot better than one of my classes. Okay. Moving on to number 13. It's similar. In fact, it's even a little easier. Who taught the last one? Person on the right? So person on the left, explain how to do this right with the blanks. Seems like most of you guys are done. Here we go. You got 9 spots. Hopefully there's 2 ways you could approach this actually and get the right answer. But if we say that, look at that last spot. The coach wants the pitcher to be last. You say there's only 1 choice for that. And then go back to the beginning and say 8 people left, 7, 6. Or I've had some people explain it differently. That also works. And they just say, I can't put the pitcher in this first spot, so I only have 8 choices. They just do it that way. And they just keep going all the way to the end, and then they say, I get to the end, and then they say, and there's only 1 choice for that last spot because the pitcher has to be there. But you can start with it or end with it either way, as long as you get that same combination of numbers. All right, let me challenge you with this. What if they had said the pitcher has to either be first or last? What does that or word mean again? Adam. So here's the way we just did it, was to put the pitcher last. Then, or we could put the pitcher first. And then there's only 1 choice for that spot. And then there's 8 choices. 7, 6, 5, 4, 3, 2, 1. And that's the same pretty much thing as this, but it says or. That means we figure out all of these ways plus all of these ways, which are different. The pitcher's on the left now. And or means we do what to them? Add them. All right. I want to stick with or being add so that I can be consistent on that. All right. I have a couple more to try. I'm going to pause while we do those so we can fit them all on the tape. We have, on the first one, there was a C because it didn't matter what order. This one, it matters what order because they're competing. So it would be 9P. And how many? 3. All right.